today we're going to talk about logs, right? And log properties. And we talked about this already before, but if we're going to talk about a common log, okay, a common log, for example, if I told you log to the 5, what did we talk about yesterday when there's no log base written, what the base actually is? 10. So that's a common log, right? In other words, a common log is something that has a base of 10. Right? Now then we'll move on to properties of logs. And the first, we're going to talk about, I think, 3 properties. The first one is the product property. And the product property looks like, if I gave you log base b, we're going to use a bunch of letters here, log base b of m plus log base b of n, okay? Then what you can do is, if you have 2 logs, and you'll notice here that the bases are the same, both are base b, then the m and the n, you guys, you can write it as 1 log. And all you do is take log base b, same base, and you multiply the m and n together. Okay, that is the same thing. So if you're looking for an exponent, okay, and you can't find the exponent one way, you can't find it the other, sometimes by putting them together you can. Right, and this is what I mean by that. So if we tried this problem, if I said log base 6, 4, plus log base 6, 9. You'll notice they're both base 6, and it's an addition. So addition turns to multiplication.
Log base 6, 13.
Log base 6, 9 times 4 is 36. Now then the question is, how am I going to get, does this have an answer? How can I get from 6 to 36? What's the log here? What's the exponent, in other words? What is it? How do you get, what exponent gets you from 6 to 36? 2. Okay, and sometimes they're very simple. In other words, look back at the problem. In this part, I can't get from 6 to 4 with an exponent, and here I can't get from 6 to 9 with an exponent. But when I multiplied the 9 and 4 together, I was able to come up with an answer. Right? It's a property that works. Let's try B. If I gave you log base, this one's a little messier, log base A to the x plus 5 plus log base A 3. Again, it's addition, which gives us the property of multiplication, right? So in other words, the bases are both A, so we're just going to multiply these 2 things together. So this would be log base A of a 3 times x plus 5. Now you're going to distribute that x plus 5, so you end up with log base A of 3x plus 15. That one is not as pretty as A, okay? It's a little messier. So guys, that is the product property. Right, so next, the next property we're going to talk about is the quotient property. So in the product property, now we're going to move to the quotient property. Now, if adding meant we multiply, what do you think is going to give us division? Subtraction, good. So if I told you log base b m minus log base b n, subtracting of 2 logs is the same as division. So this would give you log base b of m divided by n. Let's try a few of those type of problems. So if I said log base 7 of 98 minus log base 7 of 2, it's subtraction. So since it's subtraction, what are we gonna do with the 98 and the 2? We're gonna divide them. Excellent. And the 98 goes on top. The first number goes on in the numerator. So this is the same as log base 7 of 98 divided by 2. Okay, well, we don't have calculators, so if you do your head, what's half of 90?
45.
It's
Right.
49.
So then you end up with 45 plus half of 8 is 3, so 49. So log base 7 of 49. Does that have an answer? Can you find a log here? What exponent gets me from 7 to 49? 2. So the answer is 2. So let's try another one. We'll do one that's not quite as pretty again. So log base 2 of x plus 4 minus log base 2 of 2. Which we can find the answer of the second log. This answer right here is just 1, right? To get from 2 to 2, you use 1 as the exponent. Okay, but I don't know the answer here. And subtraction means you're gonna divide. So log, if you have the same bases and it's subtraction, you can divide. They have to have the same basis for the property to work. So log base 2 of x plus 4 over 2. And you can't simplify. Does the 4 and the 2 reduce? No. So this is just your final answer. That's as far as you can go with that one. Okay, so the last property we're gonna look at of this is the power property. Okay, the power property, and here's the rule. P log base B n. So in other words, if you look at this, you've got a number in front of P. I'm sorry, a number in front of the log, right? If you have a number in front of the log, guys, when you rewrite it, it becomes the exponent of n, right? So what this actually is the same thing as is log base b, and you're gonna move the p to the exponent. So it looks like that. It's called the power property. If you have a number in front, it's the same thing as the exponent. Alright, so let's try a couple. Here's A. If I told you 3 log 4, what's the base of that? It's not written, so what is it?
10.
It's 10. Okay. You can write the 10 or not, it's up to you. Now the property says if you have a number in front of the log, it becomes the exponent of this 4. So this is the same as log 4 cubed. What is 4 cubed? I'm sorry. Yeah, it's the same as log of 64. Okay, and there's a little 10 down here. If you think about that, the base is 10. Can you get from 10 to 64? No. And you can't rewrite it with common bases, which is what we learned to do on, I think, Monday, because you can't rewrite 10 anyway. Okay, there's no perfect anything that fits in a 10. So this is the answer.
Do we have to write 10? And then
No,
answer?
good question. She said, do you need the 10 there? No. I just put the 10 there to show you that it is there. You go to B. If I say 1/3 log base 6 of 64. So this property is trying to show you that if you have a number in front of the log, that it becomes the exponent. So this is the same thing as log base 6 and the 64, the 1/3 becomes the exponent of the 64. When you raise something to the 1/3, if you want to do that in your head with no calculator, what are you trying to do? You're trying to find the what? The cube root. What's a cube root of 64? Good, 4. So this is the same thing as log base 6 of 4. Now, you can't find this value. I can rewrite 4 as 2 squared. but I can't rewrite 6 as 2 to any power. If this was an 8 and a 4, I could do it. So that's as far as you can get. Go to C. 2 log base 3 to the x. It's the same as log base 3 to x squared. Okay, and then your last one, we're gonna go the other way. What if I give you log base b x to the 7th? We're gonna go the other way. And I'm just showing you the power property. I'm gonna go the other way. What does that become? If you have a power, where, if you wanna rewrite it, where does this 7 go? Good, in front. The 7 goes in front. So now it's 7 log base b of x. There you go. All right, so that's your 3 properties, right? Okay, I'd like to say we're done, but we're not. So now then let's move on to something a little different. And I want to talk about something we really focused a lot on yesterday, but I just want to remind you. If I'm asking you for the inverse property of log and exponents, what's the inverse property of a log? Exponential. And what's the inverse property of exponential? A log. Right, just like me saying, what's the inverse of multiplication? Division. Okay, so I just wanted to remind you that if I said 3 to the x power equals 9, if I wanted to perform the inverse operation, if I wanted to solve for x, then I could put it in log form. You would have log, the base of the exponent, you can use circle math, remember? Base of the exponential is the base of the log, and then there's your 9 equals your x. That was just a little refresher. Okay, so then let's change up it a little bit, and I want you to actually simplify these. We did this on Monday, so this part's just a reminder. So if I say that log base 3 of 3 to 11, I was going to ask you to solve that. Directions are simplified. I'm asking you for a log, which means I'm asking you for an exponent. And in this case, the base is 3. How do I get from 3 to 3 to the 11th? What power is going to get me from 3 to 3 to 11? 11, good. Okay, if you don't see it, right, if you would like to write it out differently, you can set equal to x and do circle math. 3 to what power gives me 3 to 11? Right? The bases are the same and the exponents match. So the answer is 11. What gets me from 3 to 3 to 11? 11. Okay, B. What about if I said log base 3 of 81? Does anybody remember? Can I get from 3 to 81? In your brain, if you want to think about it, you're going to say, if you set equal to x, 3 to what power gives me 81?
4.
Good, it's 4. You can actually get there. The other way that some kids might want to look at it is rewrite it with common base. Right? 81 is 3 to the 4th. Either way, but the answer is 4. Okay, now we're going to use our properties. So we're going to use the properties. I want you to express as a log of a single number. Express as a log of a single number. We're going to use our properties now, okay? So for number 1, if I give you log base b 3 plus log base b 4. The directions were expressed as a single number. Think back to our properties. The bases are the same, they're both base b. And if I'm adding, what does it mean I can do with the 3 and the 4? I can multiply them. So I can rewrite this as log base b 12. Okay, so this is the same as log base b 12. And you can't go any farther because you can't get from b to 12. You can't find the log, right? I can't find the exponent that's going to get me from b to 12. Okay, number 2. What if, this is just a little reminder. Here's a little bubble problem here for a second. Remember I told you that if 4 log a 2, what property would that turn into? I was going to use the property for here. What does the 4 become? Becomes the exponent, right? So this is the same as log a 2 to the 4th power, which is the same as log base a, what's 2 to the 4th? Yeah, 16. That's just a little reminder problem, because we're going to use it in the next problem. Okay, so for number 3. If I tell you log base 10, so I'm not going to write it, so log x minus 3 log y. Okay, this is subtraction, which means it's actually,
Division.
right, if it's subtraction, it's actually division. And this time, there is a 3 here, so it turns to this, doesn't it? So the step I'm gonna write right now, you don't have to write every time, but because it's notes, I'm just gonna write it for you. This becomes log base x minus log y cubed. That's what that actually is. And since it's minus, we're gonna divide. And remember, the first number belongs in the numerator. So what you really have is log x over y cubed. So here's number 4. 2 log b f plus log b g.
You can keep the y cubed on the bottom. You don't have to.
You were saying, right, is y the negative 1/3? I mean, no, it's fine. I mean, negative 3. Yeah, you can leave it. Because it's division. Okay, now this is addition, which means it's gonna turn into multiplication. Don't forget then, this step you don't actually have to write, but this is the same as log b f squared plus log base b g. And addition means we're gonna multiply. So your answer is just log base b of f squared g. All right, number 5. Log base a 7 plus log base a 6 minus log base a 3. There's 3 here, right? But let's think back to just some common. Let's think back to just something in common. If I asked you to take 3 plus 4 minus 2, right? You would do the first 2 first, that would give you 7, and 7 minus 2 then would give you 5, correct? Same here. You're going to do the first part. You're going to do this part first, get an answer, and then move on, okay? So since this is plus, this becomes log base a of 42. 6 times 7 is 42. Minus, now you have log base a 3. Now what are you going to do with the 42 and the 3? You're going to divide them. So 42 divided by 3 is 14. Okay. You got it, kind of?
We went the 2 unsee that one.
Now, if you understand that, then what you've just done is you've gone from expanded form to condensed. So now we're gonna go the other way. We're gonna go from condensed and expand.